Okay, good morning, good afternoon, wherever you are. Today we're going to be talking about tangents, tangents of lines that are tangent to a circle. Now, as you get into higher level mathematics later in life, you're going to deal with tangents a lot. All right? Tangents actually become one of the more important principles of higher level math. All right, so what is a tangent, right? That's always the first question. So let's make a circle here. All right. So what a tangent is, it's a line that touches a circle at exactly one point. So if I was looking at this shape, it would be a line, right? This green line. It would be tangent to the circle, and we can't see it obviously, but it would be touching the circle at only one point. Remember, we already talked about secant. Secant touch the point circle at 2 points, right? Secants touch at 2 points. But we're going to be talking about tangents today. All right. Now, the important thing to know about tangents is this. Wherever it's tangent to a circle, it's always going to make a right angle with the center. The tangent is here, okay? So the point of tangency, this is called the point of tangency, right? That's the point of tangency. That point of tangency will always make a right angle from the center, right? In fact, what it is, it's the shortest distance from that circle to the middle of the circle, so it's a right angle, right? That same distance thing. All right, so tangents always touch the circle at a right angle to the center. All right, so the first thing we're going to learn about is if we have two tangent lines to a connected at a point, right? So we have this tangent line A and this tangent line B, right? These are both going to be right angles, right? Now look, what you can say about these tangents is they share the same radius, right? So this side is the same. They share this middle segment, right? I should have drawn this a little bit better. Let me draw this a little bit better. All right, so they share this line, right? So hypotenuse leg says these triangles are congruent, right? Because they share a hypotenuse, right? Let's see, this red line here is the hypotenuse, right? And they share a radius, which makes their legs the same, and it's a right angle. So hypotenuse leg says these triangles are equal, which means that A is equal to B. And that is the first thing that we're going to do in these notes, is talking about when something is tangent, right? When something is tangent, these two are going to be equal. RS is going to be equal to TS, okay? And also don't forget these are going to be right angles, right, with the center. All right, that's the first thing. All right, so let's do example 1. So you're going to see this, and at first glance you may be thinking to yourself, well, there's not enough information to solve it, but there is. All right, they're going to like hiding right angles from you, and they're going to like to hide radiuses from you. So first things first, we know that AB is tangent to the circle, so this must be a right angle, right? And this is a radius, this red line's a radius, and this is a radius, so this must be 8. So what do we have here? We really have, if I blew this up, right, we really have, this is 17, and this is 8, and this is x, right? I guess I kind of drew that poorly, didn't I? Yeah, I did. Let me fix that. It's actually like this, right? Like this. 8, and then we'd have to figure out what this is, right? That's x. Well, that's a Pythagorean triple. You may not know this one, but if you do 8 squared plus 15 squared, you do get 17 squared. So x is 15, okay? If you don't believe me, you can do the Pythagorean theorem for that one, okay? All right, next problem. All right, notice, right? They don't say it. Oh, they do. They say assume that they're tangent, right? So CB is tangent to the circle, and CD is tangent to the circle. And remember, if they're both tangent and they both share a point like this, these must be equal. So x plus 3 must equal 7, so x is 4. I'm going to check something real quick. All right, we're good. All right, so real easy. If two lines have the same starting point, right, and they're both tangent, they're going to be equal. So just make them equal to each other. All right, next problem. All right, once again, this is 15, right? Because they're both radiuses, right? This is a right angle, right? So we can't, oh, I guess we don't even need that 15 really, but we could know that that was 15. All right, so what do we know? Well, there's a right triangle here, right? So 15 squared plus 20 squared equals x squared, right? So what is that? 225 plus 200, check that, 400. I'm going to switch the side here. Can I switch the side? I could. All right, well, 400, right? So this will be x squared, right? So 625 is x squared. So x is 25. If you do the square root of 625, it's 25. So x is 25. All right, next problem. 2-second problem. Ready? They're both tangent, right? They're both tangent. So they're both equal. So x is 12. Easy. All right, next problem. All right, so they say this is x, right? From here to here is x. Well, what else do I know? Well, we assume that this is a tangent, right? So there's a right angle. And this is 15. And this is also 15 because they're both radiuses. So this is 15. All right. Now let me give you a piece of advice. Instead of calling this 15 plus x, okay, I would just call this y, all right? Because you can solve for y and then you can solve for x. If you call this 15 plus x, when you square it, you get into some quadratics and it's not worth your time, okay? So it's better in a case like this to not call this side, this hypotenuse 15 plus x, just call it y and watch what happens. We get 15 squared plus 36 squared equals y squared, right? So we get, what is that, 225 plus, oh, I don't even know what that is. I have to look it up here. 36 squared is 1296 equals y squared, right? So add 225 to that, plus 225, 1521, and then square root that. I'm just going to take it to the 1/2 power because I can't do square roots on here for some reason. 39. So y is 39. Now be careful. That's what this is, right? From here to here is 39. So then what is x? Well, x plus 15 must make 39, right? So x must be, what is that, 24, I guess? So x is 24. All right. Now, that's a better way to do that. If you had left it as 15 plus x, then you would have had 15 plus x squared, and you would have had to done a Punnett square for it. It's much smarter to just call that y and do it from there, okay? Sometimes that's not going to work, but it does work here. All right, next problem. All right, what do we know? This is a tangent, so this is a right angle. So that's 21, that's a radius, and this is also 21, so that's 21, right? Okay, so we got really a right triangle here, right? What do we have? 21, x, and 29, right? That is a Pythagorean triple, but you probably don't know that one. So 21 squared plus x squared equals 29 squared, right? 441 plus x squared equals 29 squared, which is, what is that? 829. Wow. Okay, the math team's gonna start judging me here, right? 29 squared, it's been a long summer apparently. 841. Dang it, I knew that. 841, so x squared is equal to 400, so x is 20, right? So x is 20. Pretty easy. All right, same thing going on in number 6. I'm not even going to do it, right? Just do 24 squared plus 17 squared equals x squared. Easy. All right, on to the second section. All right, well, so what does this say? When a polygon is inscribed or circumscribed means around a circle, all the sides of the polygon are tangent to the circle. Okay, so what are we saying? We're saying these are all right angles, right? Right angle, right angle, right angle, right angle. They're all tangent at those points, yeah? That's all we're saying there. So these are tangent here, 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 and here. That's all we're saying, all right? And thus, these pieces would all be equal, right? All these spokes would be equal because they're all radiuses of the same circle. All right. All right. A, B, C is circumscribed about O, right? So now what we're going to do is we're just going to look at these as, when I was first looking at this earlier today, I was trying to do much harder problems. But it's really easy to do. let's just look at, in a sense, kind of ignore all this over here and just look at this. Well, what do I know? Those are both tangent to the circle, right? Right here, right? So those are equal. Oh, so this is 12. Right, that's 12. And if this is 6, then this is 6, because you see it right here? They're both tangent right there. And if that's 8, that's 8. It's real easy. So if they ask me what's the perimeter, well, what do? I just add up all the sides, right? What is this side? 18, 20, and I think 14, right? 18, 20, and 14. So the perimeter is 18 plus 20 plus 14. So 20, 38, 48, 52. The perimeter is 52 units, right? Okay, what did I do? All you have to do is recognize that this part right here is what we've been doing up here, right? This piece is equal to this piece. That's it, real easy. All right, next problem, problem 1 on example 4. All right, so what do we know? Well, this is 13. What else do we know? Well, this is 17. How do I know that? Because they're both tangent here, so these are equal, right? This is 10 and this is 10, right? So can I find x? Sure. X is 10 plus 13. So x is 23. Easy. Next problem. That's 18. So right here is 18, right? From here to here is 18 because these are equal. This is 14, so this is 14. And if this whole thing is 26 and that's 18, then this piece must be 8, right? So this must be 8. So x is 8. All right? All right, next problem. All right, well, there's a tangent, both tangent here, right? Both tangent here, so these must be equal. So 8x must equal to 2x. 8 must equal 2x, so x is 4. I'm telling you guys, these are simple, right? Then find the perimeter. Oh, I didn't do that on the first two. Hey, you could go back and just add up all the sides to get to the perimeter. Let's just go ahead and do that. The perimeter is, what is this? 30 plus 23 plus 27. So what is that? 50, 60, 70, 80. The perimeter is 80 on that one. And what do we get here? The perimeter is 26 plus 18, 19, 20, 22 plus 32, I think. You can check my math for me if you need to. All right, so just add those up. 20, 48, 50, I think 80 if I'm not mistaken. Yeah, perimeter's 80. All right, we'll do a couple more of these. All right, so let's finish this up. All right, so x is 4. So this is 8, right? So this is 8, this is 8, this is 8, this is 8, this is 8. You play with the math, so it's just 6. The perimeter is just going to be 16 times 4, which is 64. Yeah? All right, let's do this one. This one looks a little more interesting, right? Okay, so this is 3, so this is 3. And this is 1, so this is 1, right? And that's 6, so this is 6. And that's 2, so this is 2. All right, that's easy. So what's x? Well, x must be 2 plus 6, which is 8. X must be 8. Easy. Perimeter. Well, that would be, this side is 5, right? 5 plus, this side is 4, plus 7 plus, and x was 8. So 5 plus 4 plus 7, so 15, 24, right? The perimeter is 24. All right, easy lesson. All right, let's do one last one. All right, this is equal to this, right? So x is 6, because 6 plus 2 is 8. All right, so this is 8. This is 4 because that's 4. This is 9, so this is 9. That's 5, so this is 5. So the perimeter will be 13, right? Because this side's 13. This side's 14. Plus 13, and I think plus 12, right? All right, so what do you get? 26, 40, 52, I believe. Check my math for me. But I think the perimeter is 52. That's it for tangents, okay, guys? It's not hard. I think you're not going to have much trouble at all with this. Just remember the two keys. Tangents make right angles, and that makes the radiuses the same, so you get Pythagorean theorems. And don't forget, if two lines are tangent from the same point, then they must be congruent. All right, good luck with this, and if you need any help, leave me a post on my YouTube channel, MathNinja.Org, or send me an email at info@MathNinja.Org. All right, have a nice day.